Yay!
Yay! Here's another problem I've seen in at least a couple of textbooks. It's kind of a fun one. I don't even know if they have this anymore, but there used to be a carnival ride where there was sort of a cylinder, like a big rotating drum, and they had people over here on the wall, and you were kind of pressed into the wall by the rotating drum, and then the floor would drop away. All right. And if the thing rotated fast enough, you would sort of stick to the wall. So this is kind of a good example of tying a number of things together that we've already done. So let's see how we would treat this. How would something stick to the wall if this thing were rotating? What's the rate of rotation? Let's figure that out. What is in RPMs, how fast does the drum have to rotate? How fast in RPM to stick the person, let's say it's a person, to the wall? Okay, let's figure that out. So usually the first thing to do is to draw the forces. This is really similar to a problem that we did, I don't even remember, a couple of units ago, maybe last unit. Anyway, it was like pushing a brick against a wall. Okay, so this thing has downward mg, gravity's trying to pull it down. And so that must mean if gravity's trying to pull it down, the friction is keeping you pinned against the wall, right? So friction, in this case, is acting up. And then this is one of those interesting examples where the normal is the contact between the surfaces, right? And it's always perpendicular to the surface. So the normal force is actually acting that way. In. Right? That's the only way the wall can push back. And I think we're done. We're done with the forces. Remember, I know this thing is spinning in a circle, so you know you're going to have centripetal acceleration, but that does not go in the list of some forces. That goes on the right-hand side. That's the result of all the forces being added together. So let's see. In the x direction, what do I have? I've got minus n, and that's it. There's only one force, so they're easy to sum. It's pointed to the left. So this must be minus mv squared over r, because at that point, the center of the rotation is where AC is pointed, the centripetal acceleration, and that's also to the left, towards the center of the circle. Cool. So those minus signs are going to cancel out, right? Okay, in the y direction, what do I have? I got friction up, minus mg, and we don't want any acceleration in the y direction. We want that thing to stick on the wall where it is. So that's going to be 0. Well, this isn't going to be too bad, right? This tells me that F equals mg. That was easy. But F is mu times n is mg, but look up there. I know what n is. N is mv squared over r, right? So mu mv squared over r equals mg. The nice thing about the ride is that the masses cancel. It doesn't matter what the mass is. Thank goodness for the people who design the ride, right? Because you don't want like adults to sink and babies to stick, or the reverse, heaven forbid. So anyway, it doesn't matter what your mass is. Everyone is going to stick if the thing rotates at the same rate. Okay, so let's solve for v. So v is just going to be the square root. Let's see, what do? I bring r up, rg over mu. That looks like the right thing. And well, that's it. We're kind of done. So let's put some numbers on. Suppose, what's a good size for this thing? Maybe it's like a large room-sized drum. I don't know. I've never been in one, but I'm just imagining. Maybe R is 5 meters. Let's say that. G is 10, approximately 10. Mu, let's say a good mu between like clothing and a wall. I don't know. Maybe it's like 0.5. Something like that. I don't know. Those are nice round numbers. So let's see. That's going to be 50 divided by 0.5. Looks like that's going to be 10. So as long as you're traveling 10 meters per second around the outside, you should stick. But what is that in terms of rotation rate? Well, we already did that. What we do to go from 10 meters per second, and then I want to convert to RPMs. And what we said was in a couple videos so far is you just divide 10 by r. This is approximate. It's pretty close. If you want to do the real thing, right, then it's like 60 over 2 pi r or whatever. We did that a couple videos ago, but anyway, this is the approximate one, so you can do it quick. So while your friends are getting out their calculators, you're already done with the problem, right? And you got a pretty close answer. So 10 divided by r, what's r? 5. So this is 10 times 2, or 20. So it's about 20 RPM. And then if you put your little squiggly line in there, you could do anything you want. That's, well, within reason. You can approximate answers. Right. So as long as this thing is spinning at about 20 RPM, you'll be fine. You'll stick to the wall. What is 20 R? Is that even something that you would want to do? 20 RPM. So what is that? A revolution every 3 seconds? Actually, that's moving around pretty quick, right? It's a room-sized thing, and you have to go all the way around in 3 seconds. That's moving pretty fast. But anyway, that's there. I mean, you go to a carnival, you get a thrilling ride, I guess. That's the idea. So this is how to put some of these ideas together into a problem that is kind of an interesting one.